Morning students, we are discussing chapter mineral nutrition, right? In this mineral nutrition chapter, right, go for the next topic. That is the fate of ammonia. What's the fate of ammonia? Fate of ammonia, right? Fate of ammonia at physiological pH. At physiological, at which pH, sir? At physiological pH, right? This ammonia is protonated at physiological pH. Ammonia is protonated to form ammonium ion. To form what, sir? Ammonium ion, that is NH4 plus. Is this statement okay? At which pH? Physiological pH. What is happening? Protonation, addition of proton to what? Ammonia, results in the formation of what? Ammonium ion. Therefore, at physiological pH, this ammonia is protonated to form ammonium ion. Okay. Most of the plants can assimilate nitrate and ammonium ion. Most of the plants can assimilate what? Can assimilate nitrate and ammonium ion. Okay. But this ammonium ion is toxic. So this ammonium ion, it should not accumulate in the plants. Okay, most of the plants, they can assimilate nitrate as well as ammonium ion, no doubt. But this ammonium ion, as it is toxic to plants, this ammonium ion should not accumulate in plants. So what a plant does means it utilizes this ammonium ion for synthesis of amino acids. Synthesis of amino acids. Okay. Most of the plants can assimilate. Most of the plants can assimilate nitrate and ammonium ion. Nitrate and what? Ammonium ion. As what? Ammonium ion. Okay, ammonium ion is toxic. Okay, toxic to what? Plants. It should not accumulate. It should not accumulate. What should not accumulate? Ammonium ion should not accumulate. Why? As it is toxic. So what plant is doing? So plant utilizes. So plant utilizes. So plant utilizes this what? Ammonium ion. Plant utilizes this ammonium ion for synthesis. For what? For synthesis of amino acids. Plant is utilizing the ammonium ion for synthesis of what? Amino acids. In plants, synthesis of amino acids takes place by two methods. In plants, synthesis of amino acids by how many methods? Two methods. In plants, what? Synthesis. In plants, synthesis of amino acids by how many methods, sir? Two methods. Synthesis of amino acids by how many methods, sir? Two methods. What are these two methods, sir? Number one. First one is reductive amination. What is the first one? Reductive amination. Okay. Second one is transamination. What is the second one? Transamination. Transamination. Okay, first one is reductive amination, second one is transamination. Go for the first one. What's a reductive amination, right? Go for the first one. What it is? Reductive amination. Okay, reductive amination. Reductive amination. Sir, in this reductive amination reaction, I am taking alpha ketoglutaric acid. What it is, sir? Alpha ketoglutaric acid. Alpha ketoglutaric acid. This alpha ketoglutaric acid, it is one of the intermediate of Krebs cycle. One of the intermediate of which cycle? Krebs cycle. This we will get in respiration chapter. Okay, right? Therefore, sir, alpha ketoglutaric acid, it is one of the intermediate of Krebs cycle. Krebs cycle is also called as a tricarboxylic acid cycle. Tricarboxylic acid cycle. Shortcut is important, TCA cycle. Okay, right? Therefore, alpha ketoglutaric acid, one of the intermediate of Krebs cycle, that is a TCA cycle. Sir, this alpha ketoglutaric acid, it's reacting with what, sir? Ammonium ion. Right, here what is involved, sir? NADPH2 is involved. Okay, in this reaction, a amino acid is synthesized by name glutamic acid. Glutamic acid. Sir, if you take this glutamic acid as a ion, we should call it as glutamate. Ion glutamate, compound glutamic acid. Along with this glutamic acid, what more is formed, sir? Water is formed. Right, here we used NADPH2, no? So what left? NADP or NADP plus. NADP or NADP plus. Okay, right. Now listen this statement. Sir, this is which reaction, sir? Reductive amination reaction. This is reductive amination reaction. Sir, which amino acid is formed here? Glutamic acid. Glutamic acid. This is the amino acid that is formed. Is this statement okay? Right. This reaction takes place in presence of one enzyme by name glutamate dehydrogenase. What is the enzyme name? Glutamate what? Dehydrogenase. Glutamate dehydrogenase. Dehydrogenase. According to a organization by name IUB, International Union of Biochemistry, IUB, International Union of Biochemistry, enzymes are classified into 6 classes. This IUB classification of enzymes you will get in coming chapter, that is enzyme. Okay, there we will discuss in detail. Just remember now, according to IUB, enzymes are classified into 6 classes. 6 classes. In that 6 classes, first class is oxidoreductases. 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 Sir, this enzyme, that is glutamate dehydrogenase, this enzyme comes under first class of IUB classification. Where that first class names are oxidoreductases. Therefore, this enzyme belongs to which class, sir? First class. What is that class name, sir? Oxidoreductases. Oxidoreductases. Okay, alright. Now listen this statement. What is the amino acid synthesized here, sir? Glutamic acid. Therefore, in plants, the first synthesized amino acid, glutamic acid. In turn, this glutamic acid synthesizes other amino acids by transamination reaction. Therefore, first synthesized amino acids in plant, glutamic acid. Okay. In turn, this glutamic acid synthesizes other amino acids by which reaction? Transamination reaction. Okay, I am writing these statements here. In plants, okay, first synthesized, what sir, first synthesized amino acid. Who is the first synthesized amino acid, sir? Glutamic acid. Okay, right? What happens next, sir? From glutamic acid, from what? From glutamic acid, what? Other amino acids are synthesized. Other amino acids are synthesized by which reaction? Transamination reaction. Okay, therefore from glutamic acid, other amino acids are synthesized by transamination reaction. Okay, this is about first one. What it is? Reductive amination, right? Now go for the second method. What it is? Transamination. Name itself indicates. Transamination, it means a transfer of amino group. What's that? Transfer of amino group. Sir, see here I wrote two compounds, right? Sir, one compound, it is donating the amino group. Therefore this compound is the amino group donor. Sir, this amino group is accepted by this compound. Okay, so this is amino group acceptor, amino group donor, amino group acceptor. Sir, when this compound donates amino group, that amino group goes and adds to what, sir? Keto group of a keto acid. Okay, it is donating amino group. That amino group goes and adds to what, sir? Keto group of a keto acid. Goes and adds to keto group of a keto acid. Then what is formed? Along with amino acid, a organic acid is formed. Okay, right? Therefore amino group is transferred from a amino group donor to keto group of a keto acid, right? I am writing this statement. What is transferred, sir? Amino group, that is NH2 group. Amino group is transferred. Amino group is transferred from where to where, sir? Transferred from amino group donor to what? Keto group of a keto acid. This is keto group, right? Keto group of a which acid, sir? Keto group of a keto acid to form amino acids. Sir, in transamination reaction, what is transferred, sir? Amino group is transferred. From where, sir? From a amino group donor. Now we want a amino group donor. In most of the cases, glutamic acid is the amino group donor. Which amino acid acts as amino group donor, sir? Glutamic acid is a amino acid which acts as a amino group donor. Therefore in most of the cases, right, in most of the cases, right, what, sir? Who is amino group donor? Glutamic acid. Glutamic acid is a amino acid, right? Glutamic acid acts as what, sir? Acts as amino group donor. Okay, who is acting as amino group donor, sir? Glutamic acid acts as amino group donor. Here I am writing two examples. Okay, first one, sir, glutamic acid, this is the amino group donor, sir. Glutamic acid is the amino group donor. It is reacting with oxaloacetic acid. It's reacting with what, sir? Oxaloacetic acid. In shortcut, we are going to call it as OAA, oxaloacetic acid. It is having 4 carbons. Having how many carbons, sir? 4 carbons. Okay, right? Sir, in this reaction, this glutamic acid, it is the amino group donor. What it is, sir? It is the amino group donor. It is the amino group donor. It is the amino group donor. What it donates, sir? Amino group. That amino group is accepted by whom, sir? Oxaloacetic acid. Therefore, oxaloacetic acid is the amino group acceptor. It is the amino group acceptor. Okay. Sir, in this reaction, what we are going to get? We are going to get a amino acid by name aspartic acid. What is that amino acid name, sir? Aspartic acid. Aspartic acid. Sir, along with this aspartic acid, amino acid, we are going to get alpha ketoglutarate acid. Alpha ketoglutarate acid. Alpha ketoglutarate acid. What we are going to get? Alpha ketoglutarate acid. Okay, right? Now go for the second example for transamination reaction. What, sir? Here also glutamic acid. I already told you, in most of the cases glutamic acid acts as amino group donor. In most of the cases, who acts as amino group donor? Glutamic acid, right? This glutamic acid, now it's reacting with what, sir? Pyruvic acid. It's reacting with what, sir? Pyruvic acid. Pyruvic acid is with how many carbons? 3 carbons, right? In this reaction, what is formed, sir? Here, who is the amino group donor? Glutamic acid. Who is the amino group acceptor? Pyruvic acid. Then what is formed, sir? Alanine. Alanine amino acid is formed. Along with this alanine amino acid, what we are going to get? We are going to get alpha ketoglutarate acid. Alpha ketoglutarate acid. What we are going to get, sir? Alpha ketoglutarate acid. Okay, sir, we are discussing which reactions, sir? Transamination reactions. Sir, the enzymes involved in this transamination reaction, they are transaminases. Transaminases. Which enzymes are involved in transamination reaction? Transaminases. According to IUB classification, this transaminases comes under second class. Transaminases, I am speaking about enzyme. Transaminases comes under second class. What is this second class, sir? Transferases. What is the name of the second class? Transferases. First class, oxidoreductases. Second class, transferases. Transferases. What is the class name, sir? Transferases. Okay, right? Go for catalytic amidation. Catalytic amidation. Catalytic amidation. Okay, sir, in this catalytic amidation, right, what happens means amides are formed from amino acids. Amides are formed from amino acids. See here, sir, what is the general structure of a amino acid? General structure of a amino acid. This is general structure of amino acid. This is general structure of amino acid. Sir, in this amino acid, okay, amino acid, this is alkyl group, variable group. Sir, this is carboxyl group, right? Carboxyl. This is carboxyl group. Whereas this is what, sir? This is a amino group. This is what, sir? Amino group. Okay. Now listen this statement carefully. Sir, this is what, sir? Carboxyl. In this carboxyl, OH is there, no? Right? Sir, if this OH of COOH is replaced by NH2, sir, OH means hydroxyl group, alcoholic group. If this hydroxyl group of COOH is replaced by amino group, then the formed structure is called as amide. What is formed, sir? Amide is formed. See this diagram once, see this structure once, see this structure once. H R, here what it should be? NH2, right? NH2, right? NH2. Sir, COOH, right? C double bond O. Sir, OH, nothing but hydroxyl group of COOH. This OH of COOH is replaced by what? Amino group. Then this formed compound is called as amide. What it is called as, sir? Amide. Therefore, amino acid changed to amide, catalytic amidation. Okay. Sir, how a amino acid changes to a amide, sir? Right. Hydroxyl group. Hydroxyl group. Hydroxyl group means OH, right? Hydroxyl group of COOH, what happens? Replaced. Replaced by what, sir? Amino group. Replaced by which group, sir? Amino group, that is NH2. See this statement once. Hydroxyl group of COOH, it is replaced by amino group. What is replaced by what? Hydroxyl group is replaced by amino group. Then what we are going to get is called as amide. Now see this statement. Sir, see this two structures once, amino acid, amide. Sir, in this amino acid, I am speaking about this what I wrote on the board. Okay. Sir, having how many nitrogens? 1 nitrogen. Amide having how many nitrogens? 2 nitrogens. It means amides contains more amount of nitrogen than its amino acids. Therefore, amides having more amount of nitrogen than its what, sir? Amino acids. Therefore, amides contains high nitrogen to carbon ratio than its what, sir? Than its amino acids. Is this statement clear? What is the statement that is? What I told just now? Right, amides. Amides contains what, sir? High nitrogen to carbon ratio than its amino acids. Okay, here I am giving two examples for catalytic amidation. Catalytic amidation means amide should be formed from amino acid. Yes or no? Right? First one is glutamic acid. Sir, if you take this glutamic acid contains 1 nitrogen, right, and 5 carbons. 1 nitrogen and 5 carbons. Okay, right? Sir, glutamic acid is an amino acid, sir. It means glutamic acid contains OH. Yes or no? Of COOH. This OH of COOH is replaced by what, sir? Replaced by amino group. Then what is formed? Amide is formed. What is the name of that amide? Glutamine. What is that amide name, sir? Glutamine. This glutamine contains 2 nitrogens, right, and 5 carbons, C1s. Sir, 1 nitrogen, 2 nitrogens. Therefore, high nitrogen to carbon ratio, then it's amino acid. Okay, right, sir, what is its amino acid? Glutamic acid, because this is formed from glutamic acid. Second one is aspartic acid. What it is, sir? Aspartic acid. Sir, aspartic acid is an amino acid. OH of COOH in aspartic acid. OH of COOH in aspartic acid replaced by NH2. Then a amide is formed by name, what, sir? Asparagine or asparagine. Okay, clear. Therefore, see this statement. Sir, these two are amino acids. Whereas these two are what, sir? Amides. These two are amides. Okay, right. Sir, this glutamine and asparagine, these are two important amides in plants which are present as a structural part of proteins, right? Important, right, amides, important amides in plants, right, which forms, what they forms? Which forms structural parts of a protein, which forms what, sir? Structural parts of a protein, which forms structural parts of a protein. Okay, therefore amides contains more amount of nitrogen, yes or no? Therefore, sir, amides having high nitrogen to carbon ratio. Amides contains high nitrogen to carbon ratio, right? Now listen this statement. In some plants, for example, take a soybean, scientific name I am writing, glycine max, soybean, Fabaceae family, no? Fabaceae. Sir, in some plants, nitrogen is transported. Nitrogen is what, sir? Nitrogen is transported. Nitrogen is transported from where to where, sir? Nodulated parts of a plant to non-nodulated parts of a plant. See this statement? Sir, soybean, Fabaceae, nodular roots. In nodules, what is fixed? Nitrogen is fixed. What is fixed? Nitrogen is fixed, right? This nitrogen which is present in the, right, nodules, this nitrogen which is present in what, sir? Nodules, it is moving to non-nodulated parts of the plant. It means the parts of a plant without nodule. Okay, right. Therefore, nodulated part of the plant to non-nodulated part of the plant. What is transported? Nitrogen is transported in the form of urites or urites. Urites. Sir, what is transported? Nitrogen in the form of what? Urites. Nitrogen is transported in the form of urites from where to where, sir? Nodulated parts of the plant to non-nodulated parts of the plant. Sir, what are these urites, sir? Crystals of nitrogen. Crystals of nitrogen called as urites. These urites also contains a high nitrogen to carbon ratio. Therefore, urites also contains a high nitrogen to carbon ratio. Is this statement okay? Right. Sir, you are saying that these urites are transported from nodulated parts of the plant to non-nodulated parts of the plant. Through what, sir? Through xylem. Through what, sir? Xylem. Through xylem. Through xylem vessels. Through what, sir? Xylem vessels. Through xylem vessels. Along the transpiration stream. Along the, what, sir? Along the transpiration stream. Along the transpiration stream. What is the meaning for this statement, sir? See, sir, in response to transpiration, water moves through the xylem vessels. In response to transpiration, right, water moves through the xylem vessels. That movement of water through xylem vessels in response to transpiration, nothing but a transpiration stream. Along with that water which is moving through xylem under the influence of transpiration, the water which is moving through the xylem vessels, along with that water transported, urites are transported from nodulated parts of the plant to non-nodulated parts of the plant. Okay, right? Thank you.